Hello and welcome, my dear grade 9 elite students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to part 2 of the last lesson, Simplifying Radical Expressions. In today's class, our learning objectives would be to solve word problem on square roots and to simplify cube roots using prime factorization. I would highly advise you to watch part 1 of the video. The link will be in the description box before you proceed with this video. And a humble reminder, if you've been watching my video and liking them, do subscribe to the channel, like and share this video with your friends. So let's start today's video. Let's solve this word problem on square roots. Sarah uses an online calculator to determine how much interest she would accrue in a savings account after 2 years. She plans to invest $750 and the calculator determines that she could have $780 after 2 years. She can find the interest rate R of the savings account by using the formula R equal to square root of A divided by P minus 1. Now, as you see, I have already highlighted the important information here. A is representing the amount after 2 years and P is representing the initial investment. We need to find what is the interest rate. So we are going to use this formula R equal to square root of A divided by P minus 1. And if you see, A is given here $780 and P is given $750. So we can put that in the formula, solve, simplify and get our interest rate. So let's see in the next slide how we are solving this question. Okay, so the formula that we are going to be using here is R equal to square root of A divided by P minus 1. A is given to be $780, P is given to be $750. So we can put that and then simplify. So if we are to simplify, we'll cancel the zeros. Now we can easily simplify by dividing this with 3. So when we divide with 3, this comes out to be 26 over 25. So 26 over 25 square root is there. So if you simplify the square root, then it can be on the numerator, it can be on the denominator. Now 25 is a perfect square of 5. So this is square root of 26 over 5 minus 1. Now to simplify this, you may use your calculator. And this roughly comes approximately 0.02. So now 0.02 is the decimal. To convert it into percentage, we multiply by 100. So this is going to remove the decimal and give you 2%. So approximately 2% is the interest rate. So you saw how you can solve the word problem on radicals on square root using this method. Now let's move on to cube roots. I hope you remember that cube roots has index equal to 3 as you see here outside the radical, and 3 tells you that you have to now search for pairs of 3. So how can I write this as pairs of 3? I can write this as 11 multiplied with 11, which is 1 to 1, multiplied with 11. So I know that 11 is the cube root of 1331. So here 11 would be the answer. Let's take another example. Now 683 is not a perfect cube, so we are going to go to the technique of prime factorization. We had used prime factorization in the last video on square roots, and we are going to use it for cube roots also. Now this is an even number. We start dividing with 2. So 3, 4, 3. Now it's an odd number. I divide with 7. So this is 4 and 9. Again with 7. So 7, 7 and 1. So you get 686 as 2 multiplied with 7 multiplied with 7 multiplied with 7. Now when you take cube root of 686, you are taking cube root of 2 multiplied with 7 multiplied with 7 3 times. Now because the index is 3, you are going to take pair of 3 outside. So 7 comes out and inside you are left with cube root of 2. So definitely, as you see, your answer is B here. So use prime factorization for finding cube root. Let's do a question on multiplication also. So in multiplication, we are going to use the same concept of prime factorization to get to the cube root. And here you see that two radicals are multiplied having the cube root. So we have to do the prime factorization of 1690. So it's an even number. We start with 2. So 8, 4, 5. Now it's a odd number, so we do with 5. What do you get? 5 ones are 5, and then you get 2, 3, and 9. Okay, now this is perfect square of 13, so this is what you get in the prime factorization. So 1690 is equal to 2 multiplied with 5 multiplied with 13 multiplied with 13. Okay, so when I take cube root of this, it will be cube root of this. Now if you see carefully, there is um, no pair of three pairs where you can get it out of the cube root. So you can just multiply. This is cube root of 10 and cube root of 13 3 times, cube root of 13 3 times. Now when you multiply, there's already 113 outside. So this thing will be taken out and there will be 3 13s now which can be taken out of the radical. What is left is 10 cube root of 3. So this pair 3 times it comes out of the radical, so you get 13 times 10 cube root of 3. So again the answer is B here. Let's do one question on division of cube roots. So I will distribute the cube root to the numerator and to the denominator. Now denominator is a perfect cube of 2, so for numerator we will go to prime factorization. So 1 8 9, we are going to do it with 3. So 6 and 3, again with 3, 21, again with 3, 7, and so on. So 189 cube root would be cube root of 3 multiplied with 3 multiplied with 3 with 1 7. Now 3 is already in cube form, so it will come out of the radical. What is left inside? 7 with 3. So now you multiply. In place of the numerator, you can put this value of the prime factorization over 2. So what is your answer? The answer is C. So we used here the questioned property of of cube root of radical. Okay, let's solve this question, and in this question we are going to do some sort of cancellation. We first do the prime factorization of the numerator and denominator. So 3 and 3 is going to cancel, 2x is going to cancel with 2x. So you are left with cube root of 5 y to the power 3 z to the power 4 over 3 cube x to the power 3. So this y cube and this will come out of the radical because it's in pair of 3. So y over 3x and cube root of 5 z to the power 4. Now z to the power 4, 1z will come out. So yz over 3x and 1z will be remaining. So 5 to the power z. This is your final answer. Let's do one more problem. It's a multiple choice problem, as you see. Again, an important one. So first of all, you will cancel anything common that you see. So this is coming out to be 11 x to the power 4 z to the power 3 over 8 y cube. Now, it can be reduced to numerator separately and denominator separately. It is cube root, so it will be having 8 is a perfect cube, y cube is perfect, z cube is perfect, and x to the power 3 will come out. So what is left? X to the power z, xz will come out. So inside 11x over 2 times y. So this is the answer. Let's check which option matches. And here this is cube. So here definitely A is the answer, as you see, and we had used the concept of prime factorization for this question. That's all for the session today. I hope you found the video useful and you have learned about cube roots well. Do solve your math problems from the book and let me know what more topics of video you want in the comment section. If you have any questions and query, do let me know in the comment section. Until then, this is Ms. Ruchika signing off from this session. See you in my next video. Bye students.